In 4-2, we're going to be solving systems, this time using the substitution method. Substitution, remember, just means like replacing and that kind of idea, so we'll get into that here in just a second. Before I dive into this, I just want to show you an example. So if we're trying to solve by the graphing method, so here's just kind of an example. I could, both these have y by itself, that's great. There's a graph here. I could easily graph both. So this one starts at 3, goes up 1 over 2, up 1 over 2, so boom, there you go. This one starts at 5. The slope is down 1 over 1. There's the second line. And they do cross. There is an intersection point. But here's the limitations of graphing. Even though it's easy to graph, it's not easy to find where they actually intersect. It's not a precise point. Maybe it's like 1 point something, then 3.5 maybe, or something like that. So I can maybe have a rough idea of the answer, but I don't have the precise answer. So graphing is good when you have y by itself, you have a graph, they're easy to graph, and you can tell that they cross at a nice point. When it doesn't, we need to go to other methods, and that first one we're going to learn about is substitution. So what you want to look for with substitution is there a variable by itself? So I'm going to look at these two equations. This one does not have any variable by itself. I mean, you have a 3 with the x and a -8 with the y. They're both on the same side. Versus this equation, you have y by itself right here. So what's actually going to happen here is you're going to take this part here from this equation, and you're going to plug that in for y in the second equation. We're going to replace. Instead of y, I can put what y is equal to. Sometimes it could be x, sometimes it could be y, and that's what step 1 is. Substitute what the variable equals into the other equation. And we're going to solve. So let's see what happens here. It'll look something like this here. So I'm going to have a 3x minus 8. That doesn't change. But instead of the y, look, I'm putting all of this, the 6x plus 7, right where the y is. So you need parentheses, and you're putting all that equation in where the y goes. And then notice we just finished it with an equals 4. So it's all of this equation, but instead of y, put little parentheses and put the other equation right there. Now, if you notice, we only have x's, so we're just going to solve like we've normally have done in the past. So, you might start by distributing the -8. So -8 times 6 is -48. -8 times 7 is -56. Okay, so we have some bigger numbers here, and that happens at times. Sometimes you have some really nice easy numbers. So it just all depends. Let's see here. I can combine these. We're solving like we normally do. 3x minus 48x is -45x. I think I'm going to want to add the 56 to the other side to get rid of that. So we got -45x equals 60. And the last thing is I have to divide by -45 on both sides. And so we get maybe not the nicest of answers. So x equals, if you use a calculator, you get -1.3 repeating. Or you could just get -4/3 if you reduce the fraction down. So I'll accept either way. Most of the time, our answers are going to work out nice. But just wanted to show you an example of like, if I were to graph these, there's no way I would have figured out that they cross at this point. Okay. More about that in just a second. So we solve for the variable that is on the left, substitute the variable that was found into one of the original equations. So I'm going to take this idea that I know what x is and plug it back into one of these equations. This one looks a little complicated. There's a lot more going on versus this one. So there's usually one equation that's easier than the other. So instead of x, I can replace x with the -4/3. So it's 6 times -4/3 plus 7. Feel free to use your calculator here. When you do 6 times -4/3 or -1.3 repeating, you actually get -8. And -8 plus 7 is -1. So actually this answer worked out really well. Maybe this one was a little bit harder to compute with not a nice number. So our actual answer, remember, we're trying to find where these lines, if I were to graph them, where they would intersect. So where they actually intersect is the x value then the y value, so -4/3 comma -1. Which again, if I were to graph both of these, it might not have been the easiest thing to graph, and I definitely probably wouldn't have come up with this precise answer from the graph. Okay. Let's try that again. So once again, we're going to go through those methods here. I've got two equations. This one looks a little complicated, a lot going on, but this one has this time x by itself. So what I could do is take all of this and this time put it where the x is. And sometimes it really helps to kind of just draw this idea, just a reminder of like what is going where. So all of this stuff is going where that x is. So I'm going to rewrite this -3, but instead of the x, I'm going to use parentheses, and I'm going to put in y minus 3. Then I just write down the rest of the equation, plus 3y equals 4. And you solve as normal. Notice we only have y's now. So I'm going to distribute -3 times y. -3 times -3 is a plus 9. This was kind of interesting. -3y plus 3y, well, that actually is 0. So I'm only left with 9 equals 4. So again, revisiting things we've talked about in the past, we've seen situations where you lose your variables and when you're trying to solve. Well, in this case, we look at what's left over, 9 doesn't equal 4. So we actually have no solution for this problem here. There's no point where they intersect. And let's revisit that. We talked about that with graphing. So remember, we could have one solution where they cross. If they're parallel, you won't have any solutions. And if they're the same line, you have infinite solutions. So if you're going along and you're solving and you have an x or you have a y, then you have one solution. Once you lose your variables, it's going to be one of these situations. So notice here, as you minus the 3x, or maybe you add 5 and minus 3x on this side, either way you do it, your x's are gone, and this doesn't make any sense. 0 doesn't equal 5. Or on this one, when you solve, you get 3 equals 3. There's no x's, but what's left does make sense. It's true, so it's infinite solutions. Okay? These definitely take some practice, and I would say that that first step of plugging one equation into the other, this is kind of tricky. But if you look at all of this stuff, like 90% of the work is stuff you've done in the past. So try some out, and let's go over any questions you have in class.